In this example, we're going to simplify expressions using the exponent rules. In part A, we have 5r squared t to the fifth times the quantity 2r t to the fourth raised to the third power. Now to simplify this, we need to follow order of operations. Just to remind ourselves and off to the side, I'll jot down one of the standard ways of remembering the order of operations, PEMDAS. Parentheses, exponents, multiply and divide left to right, add, subtract left to right. So we'll go through that as a checklist to make sure we've done each step at the right spot. So the first thing we need to look at are the parentheses. Looking inside those parentheses, there is nothing we can do to simplify what's inside the parentheses. So that tells us that the parentheses step is taken care of. The next is now to deal with the exponent. Now while there are a lot of exponents floating around, the exponent that jumps out at me is the exponent that's on the parentheses. That will be the first step of work that we need to take care of. One thing to point out is we do have this multiplication explicitly stated between what appears to be the two halves of this expression. Keeping in mind that multiplication is further down the order of operations than the exponent, that's another reason we need to deal with that exponent of 3 before we deal with the multiplication between the first and the second half. To simplify the part of the expression that involves that exponent of 3, we need to recognize that 3 only applies to what's in parentheses, so the first half, 5r squared t to the fifth, will not change, and that exponent of 3 will be applied to every factor inside the parentheses. It's important to recognize there are 3 factors on the inside. There's a 2, there's an r, and there's a t to the fourth. So each one of those 3 will get its own exponent of 3. So we'll end up with 5r squared t to the fifth times 2 to the third, r to the third, t to the fourth to the third. Now the next step is still going to be dealing with that set of parentheses that has the t to the fourth on the inside and the 3 on the outside. So the rule that we'll work with here is the power to a power rule, where we have t to the fourth, so a power on the inside, whole thing raised to the third power, a power on the outside. We end up multiplying those powers. So that again, most of this line is not going to change. We'll still have 5r squared t to the fifth times 2 to the third r to the third, but we'll simplify that last factor into t to the 12th. At this point, we now only have multiplication left. We do still have some exponents floating around, but we've essentially dealt with most of the exponent rules, so I'll check that one off. At this point, we're going to use multiplication, and we're going to multiply the common bases. So we have an r squared and an r to the third. When we're multiplying the same base, the exponents can be added. So r squared times r to the third is r to the fifth. T to the fifth times t to the 12th, same thing. Same base, so we're going to add the exponents. T to the fifth times t to the 12th is t to the 17th. Now there's going to be a trick here. 5 and 2 are not the same base, so I can't simplify 5 times 2 to the third in any other way unless I actually deal with the exponent on the 2. So 5 is going to stay what it is, but I know that 2 to the third, 2 times 2 times 2 is 8. So instead of writing it as 2 to the third, I'll write it down as 8. And so I get 5 times 8 times r to the fifth t to the 17th. And now because 5 and 8 are just regular integers and there's no exponents involved, I can multiply them, and 5 times 8 is 40. So this gives us a final answer of 40 r to the fifth t to the 17th. In part B, we're going to simplify the expression 3n to the fifth times the quantity 2n raised to the third power plus 4n squared times the quantity 5n to the third raised to the second power. For part B, I'm going to again start by writing down the order of operations. Parentheses, exponents, multiply and divide left to right, add and subtract left to right. Now again, to simplify this expression, it is important to recognize that there is addition in the middle of this expression. And it's important to recognize that addition is the least important, or the lowest ranked order in the order of operations. Because of that, this will effectively split into 2 separate expressions that I'll deal with individually, and only at the end, if I can combine like terms, will these actually get added together. So I'll work with the first half separately from the second half. In the first half, we have, in parentheses, 3n to the fifth times the quantity 2n to the third power. The first step in simplifying in the front of this expression is to deal with the exponent on the outermost parentheses there on the second factor. So 3n to the fifth is not going to change, but the quantity 2n raised to the third power will become 2 to the third times n to the third. We're applying that outer exponent to each factor in the parentheses. I'm going to finish simplifying this first half, and then I'll come back to the second half. Taking this a step further, I can combine the n's. N to the fifth times n to the third is going to be n to the eighth. And a similar thing is going to happen to our part A example. We're going to have 3 times 2 to the third. Well, we know from before 2 to the third is 8, so I can rewrite this as 3 times 8, n to the 8th. And 3 times 8 simplifies into 24, so the first half of this expression gives me 24 n to the 8th. Now again, it's okay to separate this into two separate expressions to work with, because that addition is going to be the very last thing I deal with between what's happening in the front, which involves multiplication in parentheses and exponents, and what's happening in the second half, again involving parentheses, multiplication, and exponents. So I'm going to go through and just add an addition, that's that addition sign I identified before, between the two halves. So the second half of this original expression is 4n squared times the quantity 5n to the third raised to the second power. And just like with the first half, I need to deal with that exponent of 2 first. So the 4n squared is going to stay what it is, but that outside exponent of 2 is going to get applied to both the factor of 5 and the n to the third. So we'll end up with 5 squared and n to the third squared. Well, again, I'm going to continue simplifying this. 4n squared is going to stay 4n squared for a bit. I'm going to take a moment to rewrite that 5 squared as 25, and n to the third in parentheses, raised to the second exponent outside parentheses, tells me I'm going to multiply the 3 and the 2. So that gives me n to the 6th. So that whole second half of this expression is 4n squared times 25n to the 6th. And the final step in simplifying that second half is to multiply my integers. 4 times 25 is 100, and n squared times n to the 6th is n to the 8th. Now it turns out, having done both the first half and the second half, having dealt with parentheses, exponents, and multiplication and division, we've now simplified each half. It turns out that at this point, those two halves are actually like terms. They are both n to the 8th terms. So I can now go ahead and add them together. 24n to the 8th plus 100n to the 8th is 124n to the 8th.